Hey, working with Algebra Tiles Part 2 video. Welcome. So, on the screen, we'll see tiles, and we also see expressions expressed by numbers and letters. So, when you have an expression 3x plus 2y plus 2, and it says use algebra tiles, so you want to demonstrate this by bringing as many tiles as required in order to answer the question. So note that the first term says 3x, so you expect it to show 1, 2, and 3 x's added together. I hope this makes sense. So this is the first term. The next one is 2y, so you would bring 2y, and since you're adding, you would bring positive tiles. And the last term consists of 2 units. So one red and the second red tile. So I hope you now would agree that this is representation of 3x plus 2y plus 2 as requested. The next question right below. The expression shows negative 2x minus 3y and minus 4. So we have to bring opposite tile this time. We have to bring negative x, and how many of those tiles we need to show? We need to show 2. So this is why you have one negative and another negative x. Then we have negative 3y, which means, okay, I have to bring y tiles, which are opposite to positive y. So negative y repeated 3 times, and negative 1 unit repeated 4 times. So we do answer the question by changing the written statement into a picture representation, a diagram, because we have agreed that X tile looks like a green rectangular shape, and its opposite will be negative X. It's the same size as the X green tile, but with white color. By the same token, positive y is an orange color, negative y is white, and positive 1 red, negative 1 is white tile. I hope this makes sense. So let's move to the next slide and resolve the following. It says combining like terms, and we have to group like terms by simply identifying which tiles have the same size and the same color. But before we do that, we have to identify what is given. So we have 2x tiles. So let's bring 2x tiles together. Then we have 2x squared tiles. So please note this is different shape. Then we have 1 negative y. Then we have 2y squared combined together. Then we have 2y tiles. So let me put that below. One positive y, another positive y, 1 negative x, and 2 units. However you combine them, it doesn't matter, but your goal will be to identify, can we group them together in as many groups as needed, and can we identify like terms here? Yes, we can agree that 2x group and 1 negative x group would define one common like terms group. And what is the result of adding one positive and one negative? From the previous video, you recall the zero principle. So when you have one positive here and you combine with one negative, this would cancel each other out, so you have 0 as a result. So let's delete this tile now. And delete this positive x. Okay, so this is done. Delete that as well. X squared family. Do we have any other x squared tiles? No, so that stays. Those two x squared tiles will stay, no change. Negative y tile, listed right here, is to be combined with two positive y tiles. So think of the zero principle. One negative y with positive y will make it 0. So this is y, positive y and negative y disappears. So the next one in line is 1y positive tile. Then we have 2y squared. So yes, we have 2y squared tiles. We combine them together as another group of like terms. And we have two positive units. So we did combine them together. So in the end, you can tell that it is represented, this expression, but by 2x squared tiles. Let's grab the ones with the exponent 2. 2y squared tiles, 1x tile, 1y tile, and plus 2. So this is after combining like terms, we see simplified expression. Moving to the next slide. Now it says use algebra tiles to show the following. So please note, we will be adding one polynomial with another one. So let's bring the tiles to this picture. So the first bracket shows 1x, 2y's, and 2 units. So one red and another red. So this is the first polynomial represented by these tiles. The next group shows 2 negative x. So this is why you show 2 tiles, negative x and negative x, 1y, and opposite to 1, repeated 4 times. So when we want to combine those tiles, we have to recall the zero principle one more time. So positive 1, I need to select different color. Positive 1 and negative 1 tile will be gone. Another positive, another negative. So we have eliminated those 2 4 tiles. Same idea with adding positive x and negative x. So the result of that will be 3 y tiles, 1 negative x tile, and negative 2 units. So we use algebra tiles to show the following, and as a result we have a new expression after combining like terms. And the next slide. Distributive property, very, very powerful property, and we need to understand that fully. So we have 3 outside of the brackets and x, negative 2y tiles, and positive 2. So let's do the following. I'm going to bring positive 1 and I repeat that 3 times on this side of that corner. Our goal is to create an area where one side is equivalent to 3 units and the other side is equivalent to 1 x tile. So this is why I put it sideways. 2 negative y tiles and 2 positive units on that side. So this is, imagine like working with length and width, and we have to fill in the blank. So our goal is to sort of think of what is the possibility here to enclose that rectangular shape that was created by 3 and x minus 2y and positive 2. So for each tile below, there is 3 more that you can repeat. So you can copy 3 for each unit. It's you multiply 1 times x, 1 times x, 1 times x, and that gives you 1, 2, 3x. Then you do the same thing with y tiles. So for each negative 1, you multiply it by positive 1, so you get negative 1 tile. Another step, 1 more. Then the next row of y tiles, you multiply by unit 1, and you do that 3 times. So in total you have 6 negative y tiles. And then you multiply the last tiles together, quote-unquote tiles multiplication. So you combine 1 and 1 to get 1 unit area, another 1, and another 1. And again, you do it for the last row, column, I would say. So what do we have in total? Look at the area inside. The area inside. So this is the result of that multiplication. So if you were to use paper and pencil, you would say, oh, I know what I have now. I have 3x tiles. I have negative 6y tiles. And I have 6 units in total. I hope this makes sense. So let's go and do one more question. Multiplying monomials by a binomial we call the distributive law. So similar case, but now we have variables on each side. So 1x tile goes right here. And the second tile, I need to rotate it. So this is x and 3 negative units. 1, 2, and 3. So similarly to the previous question, our goal is to fill in those tiles to enclose that area, which consists of one length as x and width x and negative 3 tiles. So when you multiply x times x, if you recall from the previous video, we would generate x squared tiles because length and width are represented by that same quantity, x times x. And then you multiply 1 positive negative 1 times positive x. So this is where you get negative 1x. And you repeat that again and again. So when you multiply one positive value by a negative value, the result must be negative. So further, if you were to explore what happens when you multiply this by paper and pencil method, x times x and x times negative 3. So this is the distributive property. X times x plus x times negative 3. And I have to simplify that. So recall the rules of multiplying the same numbers with exponents. You add exponents. Here the exponent is 1, so this is why you have x 1 plus 1. And you multiply 1 positive 1x times negative 3, so you must get negative results, so negative 3x. And finally you have to clean that exponent and say this is essentially 2 minus 3x. And this is represented by the diagram here when you have 1x tile and 3 negative x tiles. 1x squared tiles, I should have said, and 3 negative x tiles. So I hope you enjoy watching this video. It helped you to explain how to work with algebra, how to combine like terms, how to use the distributive property, and how to multiply a monomial by a binomial. Thanks for your time. See you again.